May I request to come on stage Dr. A.K. Swami, Professor, IIT Delhi, who is also an active member in various committees of IRC. Now, may I request to come on stage J. Gandhi, Sir, Chief Engineer, R&B Gujarat, to greet by bouquet to Chairman Dr. N.C. Pal, Sir. Now, may I request to come Dr. Sri A.C. Patel, Sir, Engineering R&B Gujarat Department, greet by bouquet to Dr. A.K. Swami. Now, may I request to all presenters to please come on stage. Sri Thagmani Adippa and Sri Venkata Akhilesh Dhanam, Research Scholars IIT Kharagpur. Next, Sri Surya Narayan S, Research Scholars IIT Jammu. Ms. Bhuvana Priya Dandapani, Prime Minister Research Fellow, IIT Hyderabad. Dr. Koli Mohan Krishna, Postdoc, IIT Gandhinagar. Dr. Kolaro Subham Arun, PhD, Postdoctoral Researcher, Indian Institute of Science, Bangalore. Sri G. Vamsi Krishna, Research Scholar, IIT Bombay. Sri Arjun PV and Sri Rahul Reddy B, Research Scholars, IIT Kharagpur. Sri Priyank Trivedi, IIT Research and Management, Ahmedabad. Ms. Ankita Singh, PhD Scholar, IIT Gandhinagar. Please come on this dais. Now, may I request to Chairman of Session Dr. N.C. Pal, Sir, for opening remarks.
Second Note Congress. And on behalf of organizer, I thank everyone to give this and IRC to give the opportunity to me and Dr. Swami, both of us. We chaired last time in Lucknow session this research scholar presentation. This time also we have given the same opportunity. And I hope being the technical session one, it should stimulate the today's presentation. I can find there are 10 presentations by various IITs, IIC Bangalore, School of Planning Architectures and Management Institute. And some of them are dedicated to between related aspects, some on smart structure, some on multimodal logistics. These are the current demand topic based on national and international requirement. I hope all the young researchers who have done extensive work during their research period, starting from literature survey, focusing on the objective and finally fine-tuning on the topic and doing a lot of numerical or experimental work in a very short time. Only the time allotted is only 5 minutes. So in a very short time, they will give us their exemplary output and whatever the achievement they have done. so that all the participants or delegates who are assembled here will learn from them and will also suggest their ideas or further innovation thought for the young researchers. So with this opening remark, I welcome all of you. I welcome Dr. Swami, very expert academicians from IIT Delhi, who is also a committee member in the Material Accreditation Committee with me. So since the time is allotted 5 minutes and we have already started a little late, usually the session one start little late. So I request all the participants, all the presenter to straightway start from their topic, objective, scope, and the work they have done instead of wasting much time on literature related aspects so that we can pinpoint focus what exactly has been done. Thank you. So the first one we can start is the bioethanol industry-based lignin as a partial substitute for bitumen by Sri Thabamani Anindapam and Sri Venkat Akhilesh, a research scholar from IIT Kharagpur. Fortunately, I am also ex-alumni of IIT Kharagpur. So many times we see on payment-related things, IIT Kharagpur and mostly IIT Madras, they come front, and most of the thing documented in IRC as output of those research institute in this country. Hope the Kharagpur presenter will give a nice thought to them. Yeah, you can start now. Is there any time? No, I think they must have. So try to, as I said to all the presenters, try to focus on the objective scope and straightway what exactly you have done and the output. Yeah. And after 4 minutes, we'll give a warning bell so that you can conclude in the next 1 minute. And after all the presentation, we'll go for a floor interactive interactions and suggestions from the experts and from the delegates. Thank you. I think this article is by two presenters. The presenter who will be presenting today's session may introduce his name.
Good morning, one and all present here. So the topic we are going to present is bioethanol industry-based lignin as a partial substitute for bitumen. Coming to the introduction, we all know that bitumen is a non-renewable resource, and the ever-increasing pavement projects, especially in the pavement sector, results in high demand for the bitumen, and use of sustainable materials as partial substitution or alternative can resolve this problem. The second generation bioethanol production results in lignin containing byproducts which could potentially be used as partial substitutes for bitumen. The objective of the study is to evaluate the performance characteristics of bitumen partially substituted with lignin from bioethanol residue. So the materials that have been used in this study are VG40. You can see the properties of the VG40 here. And two types of lignins have been employed in this study. One is fermentation residue lignin and one is isolated lignin. As the name says, fermentation residue lignin is a byproduct of fermentation carbohydrate content and lower lignin content. Lignin has been partially substituted in these percentages, you can see here, and the physical properties of the lignin has been measured. The softening point data is presented here. With the increase in lignin content, the softening point has increased, and there is the workability criteria is also found to be satisfied, which is less than 3 pascal second at 120 degrees, 20 RPM. Storage stability test has been carried out, and 4 degrees centigrade has been considered as a limit, because of the densities difference between the lignin as well as the bitumen. So the isolated lignin has shown improved storage stability compared to FRL lignin. This can be attributed to the contaminants and heavy metals present in the FRL. Further will be presented by its Tawal.
Please conclude. Thank you, Venkat and Thampen, for the presentation. Now, the next presentation is by Surya Narayan, research scholar from IIT Jammu, on utilization of surface modified aggregate in asphalt mixture. a sustainable solution for durable payments.
I am Surya Narayan, research scholar from IIT Jammu. This is my research work based on the research funded project from National Highways Authority of India. So this is my outline of the presentation. So inferior quality aggregates. Basically, aggregates have physical properties, mechanical properties, as well as the chemical properties and adhesion properties. So if any of these properties are not up to the mark specified in the our mark orange book or IS codes. So we have to improve them so that we can utilize them in the asphalt mixtures. So based on our location study area, Jammu and Kashmir, we have various different climatic conditions. We have very hot summer and we have winter up to 2 degree. And the problem in Jammu and Kashmir is basically the quarrying is restricted. So we have to get the aggregate from the river gravel, the boulders. Then we have to crush them in the river bed. That is the major aggregate source in the Jammu and Kashmir. So based on these problems, we have kept our objectives as to collect and characterize different aggregates present in the Jammu and Kashmir and to treat them with different chemical treatment methods so that we can effectively use them in the asphalt mixtures, and how these chemical treatment methods will
is a good work done to explore the natural aggregate of them. The third presentation is on design and evaluation of mechanical property of cement grouted bituminous mixes containing reclaimed asphalt pavement material by Ms. Bhuvana Priya Dandapani, Prime Minister Research Fellow of IIT Hyderabad.
Hello everyone, I'm Bhuvana Priya, Prime Minister Research Fellow IIT Hyderabad. I'm working with Dr. Ramya Srimunurthy, Assistant Professor IIT Hyderabad. So I'll start with the introduction. So basically, cement coated bituminous mixtures are a composite pavement material consisting of open-graded asphalt mixtures injected with cementitious grouting material. So it has various advantages over flexible and rigid pavement, and its applications are wider. So when we talk about the CGPM containing rapid linear, when comparing with CGPM with 0% RAP, and further the performance studies are going on. Here I am restricting this presentation to design and mechanical properties. And publication details, so we have published a review paper in the design and performance characteristics of CGPM review and references.
Thank you, Priya. Excellent presentation. And also nice work on reclaimed material and cement grout base. Now the next presentation is on serviceability design of geosynthetic reinforced soil walls for highway by Dr. Kohli Mohan Krishna, postdoc fellow of IIT Gandhinagar.
Good morning everyone. So I am Dr. Mohan Krishna from IIT Gandhinagar, and we have also a startup incubator at IIT Gandhinagar, and basically we work on the innovative geotechnical solutions, especially geosynthetics, for all the infrastructure problems. So today I am going to present on the serviceability aspects of GIS, especially the problems we are facing today in the highway construction. So as we all know, these geosynthetic reinforced soil walls are the field retaining structures, and we are widely using wherever the approaches we are required and wherever we need to retain the slopes. Basically, these are the internally stabilized slopes, and we are going for it over the conventional cantilever retaining walls because of their low cost compared to all the concrete kind of gravity or cantilever kind of structures. And we know this, these are constructed in the layers where we are filling the soil, and then we put the geogrids and we put the fascia, and we go till the required height for the elevation. So, and generally we design this based on the limit state methods, and it involves the stability design where we assume it as a monolithic mass so that it should not fail as a monolithic mass, and internally also we are designing so that reinforcement should not rupture and as well as it should not pull out. And there is another aspect we generally don't take care of, it is like serviceability design. Generally we check for the settlements but lateral deformations and how this deformation affects the serviceability, mainly functionality of highways. We generally don't, as a designers, we are not putting a focus on it. So why serviceability is important? Major is like functional requirement. So where we are going on the highway, we see the bumps, we have the approach, the bridge check and the animal approach, or in the between. So that is a serviceability problem. We are not getting our function what we require. So, and we require aspects also. Sometimes we put the walls as well. We feel that it will fall, but as per stability point of view, it is stable. It may stand for 100 years, but aesthetics point of view, it may not look good. So there may be cracks in the fascia, those kind of things. So these are the aesthetic point of view. So these are the serviceability aspects we need to take care of with the design. It should be part of the design. As the course also we take it, but as a designers and during the practice, we generally neglect it because mostly we focus on the stability. And as I said, serviceability, there is a design life. We design for the 100 years, but there is serviceability maybe 70 years. So as a clients, we should from the government side, we should ask for service life also. How many years it will be serviceable, not only the stability point of view. And in serviceability, there are like horizontal deformations, vertical settlements, and there are differential settlements also. So the major, maybe let's say the last structure may settle. So during this settlement, there will be different settlements between the fascia and the fill because these are both the different stiffness. So concrete and this is soil. So there will be a relative displacement. One can be related, maybe fascia settle more, sometimes soil settles more, depending upon the ground condition or how we compacting it. Sometimes contractors don't compact if we using check up. So and we are seeing several problems like that. And during involvement in different rectifications, this is a major problem. Whether we don't take care of ground settlements or we don't take care of the compaction, whether it is happened or not. So these relative settlements will happen in most of the projects, and sometimes it is more like that. So what how we are solving this is like initially in the IIT Gandhinagar as part of my thesis, we have constructed a model test, one is scale model test, and we simulated the differential settlement at the base level. And we see that as the relative settlement is increasing, the strains in the reinforcement are increased. We monitor it using a strain gauges. So as the relative settlement increases, after some point the connections may fail. So it is the thing. And the fascia settlement is also movement is also towards the fill. So it is dragging the fascia towards. So if it is an incremental panel, there will be like opening like this. So connections are failing even at the low settlement ranges also. So the worst criteria is like fascia settling with respect to the fill. Even fill settling related to fascia, there is some buffer. There can be some buffer. So which is a major issue. So to conclude that relative settlement is a major issue. There can be costs of failure. So and the worst case is the fascia settling related to the fill. And we have developed a sliding corrections. I am not showing it here, but the sliding corrections, it is very encouraging results is that there is no increase in the reinforcement strength and the serviceability is very good performance. So, and we are looking for the collaborations with the government departments also to implement the field scale, how this sliding corrections will at the field scale. At lab scale, there is no increase in the strength and they work perfectly with the concrete panels. So as I want to thank my mentors as Professor Amit Prashant is also my thesis guide, and also I want to thank Professor Jiro, always mentoring me with all these understanding all these aspects, and they are mentors to our consultancy company also to work on these innovative technologies. And for any further details, please contact me, and I am very happy to discuss the experimental things in detail, or I will share my thesis and my papers. Thank you very much.
Thank you, Dr. Krishna, for a nice presentation. And I think you have shown both experimental validation and a finite element deformation mode analysis. Thank you. We'll discuss on more that during the floor interaction. Now the next presenter is by Dr. Kalor Shubham Arun, PhD postdoctoral research fellow from IIT Bangalore on design of granular subbase layer in pavement. Though this is a very conventional topic, many of you are possibly you want to listen something very new in this research, design of granular subbase layer in pavement.
Today I'll be presenting on design of granular subbase layer in pavement and drainage perspective. So right now I'm a postdoctoral fellow at Department of Civil Engineering, IIT Bangalore. I'm working with Professor J. Kumar Institute of Science, Bangalore. So in brief introduction, as you know, the transportation infrastructure plays an important role in the development of the society. As a developing country, India plans to expand its road network, focusing on reliable and sustainable infrastructure that is also economical to society. Pavement systems are exposed to the environment that leads to an increase of pollution. As you know that there are multiple sources of infiltration, the primary source being the rainfall infiltration. There are also groundwater fluctuation that causes rise of water to the pavement system. There is also capital rise of water, and there could be also adjacent flow due to the adjacent farmland and green. As you know that water in pavement system is a problem. It acts like a sticking agent between asphalt and aggregate. It reduces the moduli of the unbounded and unbounded layers. Also, the excessive erosion might lead to loss of support. All these phenomena give rise to the formation of potholes, surface distances, eventually leads to the premature failure of the pavement. So, to control the detrimental impact of water in pavement system, we provide subsurface drainage system. So, normally for the Indian condition, we call it as a granular subbase layer. So, its functions are to provide drainage, filtration, and also it acts as a structural component. So the design is based upon the providing its adequate material, its length and distribution, and its thickness. In addition to the granular subbase layer, in order to escalate its performance, we provide geosynthetic in terms of geotextile and drainage geocomposites. So the other important phenomenon I would like to highlight is the hydraulic stability. So this is a phenomenon of the unbounded material. So we define it as the ability of a course of fraction of a soil to prevent loss of its own fine fraction due to the seepage flow. Let's say we have a uniform grain size, like the grain size of uniform sizes. When there's a flow of water through such that we don't expect the movement of its particle through its own matrix. But for the other case, if we have a broadly graded soil where there are fine particles, coarse particles, and when there's a flow of water through such soil, there's a movement of fine through it. So the problem with this phenomenon causes cavities within the coarse matrix that leads to failure. This phenomenon is even worse when we have a geotextile and a downstream side. So the final part is called clogging of a geotextiles and a drainage geocomposite. So this is a very relevant topic for the pavement system. Also at IIC, we conducted few laboratory tests in order to understand how significant this problem is for the pavement system. So we conducted few viscous tests, what we call, in order to get the critical hydraulic gradient, where they observed for internally stable gradations, the critical hydraulic gradient is greater than 1. But for the internally unstable gradations, the critical hydraulic gradient are lesser than 0.5. So those are the within the range where what hydraulic gradient takes into pavement, normally 0.1 to 0.2. So So in order to understand what type of gradation is entirely unstable, so there are numerous methods available, advanced methods are available. But for a payment engineer, one needs to have the easy method. So we propose some easy method based on the coefficient of uniformity and coefficient of curvature. So in a layman language, I can say if a coefficient of uniformity is less than 20, then we can certainly call as the gradation as internally stable. So if you look at the current specifications of the modern IFC, we have 6 gradations for the kindness of this layer. But if you see the coefficient of uniformity for these gradations are greater than 100. For the first 4 gradations, those are 100 greater than 100, but the gradation 5 and 6 are somewhere internally stable. So we propose some modification to the design of triangles of this layer. So there are 5 requirements one can go for. It's not only about gradation, it's also about the drainage thickness, the requirement for the filter, the geotextile filter, and geocomposite drainage. So coming to the configuration that one can adopt and the minimum about thickness are shown in this slide. So the option would be one can provide granular drainage layer, one can provide granular drainage layer with a filter layer if the filter requirements are critical, one can go with geotextile, or else one can go with drainage geocomposite if there's a scarcity of granular drainage layer aggregates. So these are the few recommendations that we have given for the grants of this gradation. The first 4 gradations are the two proposed gradations. So these are the developed based on the hydraulic stability requirement, as well as we evaluated the saturated hydraulic conductivity, and like 5 and 6 are the existing gradations from the board specification. Also, we have proposed some drainage design for the hydraulic purpose in order to get the thickness for the granular drainage there. So this is from the literature. Also, we have proposed some filter layer design where, depending upon what type of separate soil you have, one can design particularly for the granular drainage layer. So for geotextile filter design, also there are few specifications available from the literature we are proposing. So these are the part of the IITs 42 that we are revising, and this would hopefully will come into some future revisions. For geocomposite also, we are recommending some design approach, and there's some illustration just I wanted to show, like depending upon separate soil, one can design the required granular drainage layer. So depending upon, there could be different options one can have depending upon the 2-lane or like whether it is 4-lane or 6-lane. So the thicknesses one can evaluate based on what is the rainfall coming to the system and what is the actual site conditions.
Thank you, Dr. Arun. Your subject is written here, design of granular surface layer in pavement. The drainage is not added here. But in fact, it was in drainage, and in our audience, we have a very veteran and expert professor, Raghavan, who has done, Raghavan from IIT Chennai, who has done a lot of experiment on surface drainage related activity. I hope you must have referred those literature also in your work. Now the next presentation is exploring potential of Marshall RT as a simple performance test to evaluate rotting resistance of asphalt mixture by Sri G. Bhamakrishna, research scholar from IIT Mumbai.
PhD student at IIT Bombay working with Professor Dharmesh Singh. Today I will be presenting exploring the potential of Marshall RT as a simple performance test to evaluate the rutting system of asphalt mixes. So rutting is basically longitudinal surface depression in the wheel path. You can see in the pavement this is happened due to the densification to the irrecoverable deformation and the lateral shear flow. So if you can see there is a wheel path in the surface depression and the armpit wheel. The depression is a rutting or deformation we say. So this will cause the riding quality issues and hydrodynamic issues and the road safety issues and then potentially to the traffic accidents. And then these are some of the highway rutting in India, happening in India. And then this is what we do the mix design. Summary of the mix design we do in India as per mix design. We do the select the optimum biodeterminant corresponding to the 4% air weight, and then we check the volumetrics and stability and flow criteria, and then the third criteria is the moisture damage we check. But I want to highlight here, and then if it is satisfied the criteria, we approve the Japanese formula, and then we approve the mix design. But I want to highlight here the statement given by the Dr. Randy West, and in the field. So which is like highly expensive and then it requires additional tools like saw cutter, core cutter, and it requires significant of time, more than 7 to 8 hours. And then it requires a technically skilled person to run the test and then data interpretation. And then highly maintenance cost and it's excessively like it is not applicable in the quality control as a quality control. So this is limiting the idea practitioners to use in the field. So therefore there is a need of the simple test that can be done in the less time using the existing setup, good repeatability so that you have correlation with the field performance and practical as a quality control and quality assurance. So in Indian practice we have the criteria of the master stability. So master stability, many practitioners saying that achieving the high master stability can be the high retting resistance. Is it true? So then we conduct different plant production methods all over the India, contacting highway agencies, and we try to relate with the existing test methods. So this is the situation, we could not say any correlation. So achieving high master stability cannot be guarantee that it can perform better. So then can we develop a simple performance with the existing resources like master's setup? So then we try to come up with an idea, the master retting test, in which the master stability we use as a master stability test regime, we use the ITs or the DSR criteria. Then we combine these two to come up with a test called master RT. We have the master fixer and the ITT fixer, and then this is the setup looks like. And then this is the test conditions for the thing, and this is the failure phenomena, which is the failure planes, and then this is the comparison with the different tests. Master stability has the compression we have been, this is the different failure planes here. And then we need to once we have the test, we have the parameters. This is the typical load versus displacement curve. Based on this, we come up with the weight load and the work done for the deformation. Two parameters will come up, and these are the test results look like for the different particles mixes. And we try to correlate with the existing tests, fundamental, pronominal test, simulative test, and the simple test ideal. And this is what the correlation looks. A very good correlation was observed between this martial art and the pro number. And then we try to propose for the limiting value, preliminary acceptance value based on the pro number accepted for the 100 million MS. So, and again correlation with the preliminary acceptance limits. And then, so therefore, I want to say that national RT can be a simple, practical, and efficient test to avoid the retting resistant raster mixes with the existing resources in many laboratories in many field conditions. And I would like to thank my supervisor, Professor Darvisi, for his encouragement, support, and motivation. And payment business group IIT Bombay and Advanced Payment Laboratory. And the IIT agencies we have supplied the materials in this thing. And the IIT Bombay and the IIT for giving me the opportunity. Thank you.
Thank you, Ma'am Krishna. Now the next presenter is by Sri Arjun PV and Sri Rahul Reddy from IIT Kharagpur. It's on influence of polymer modification technique on the rheological properties of polymer modified bitumen emulsions. Please introduce, if both are presenting, yourself one by one.
Good morning, everyone. My name is Arjun, research scholar at Transportation Division, IIT Kharagpur. Currently looking under Professor Sudhakar Reddy. And my co-research scholar is working under Professor Ramya Reddy and Pratik Ram.
Thank you, Rahul and Arjun. Now, the next presentation is on stakeholder engagement-based decision-making for multimodal logistics. Ms. Priyanka Kumar, PhD scholar from SP at Delhi. I think she is not present. Now let's go for a presentation on road accident severity analysis by integrating the hybrid multi-criteria decision-making approach by Sri Priyank Trivedi from IIT Ahmedabad, Research and Management.
severity. So after that, we have cross-check our calculated data, we can say the calculated criteria weights with the consistency check, and after that we have directly applied the local priority values with the severity values to get the overall ranking. So we can say that the first Delhi is getting the first rank so we can say that Delhi is highly affected by the road accident, and as we move forward, the last is equable. So that's how we can directly apply our research. Secondly, we have also cross-checked our research with one of the other method referred as the toxics, and we have correlated our ranking correlation with the strongest Steinman coefficient, and which is resulted in 0.9. So it means our overall analysis is very strong. So after that, we have applied the gaming clustering to further divide our ranking into the three phases. So phase one, phase two. The phase one is the first severity state, phase two is the second severity state, and phase three is the third. So any stakeholder or government department can directly input, or you can say directly collaborate this road safety strategy based on this phase-wise analysis. So we can also generate this kind of thematic graph based on our data sets. So it's quite easy for someone from the government or the you can say the non-government organization to work on the safety on a particular area. So after that, we also work on the road accident influencing parameters with another models referred as the community, and directly get to the result of that particular model. We have analyzed total 82 criteria, and ranked based on the severity, so that any stakeholder from the government or the non-government or any researcher can also integrate this result with the ease, and the best outcome can be concluded based on this strategy, this ranking only. So we have also categorized this overall 82 ranking in the three particular severity state for the further and detailed analysis. And based on our analysis, we can conclude that the highest integration of all injury as well as the accident type is must to get the best outcome. And the suggested strategy can also imply on any kind of area. So let's say starting from the global scenario to a particular road state, we can apply our particular the provided model to get the best outcome. So hoping that our research is integrated with the goal of Vision Zero, goal of United Nations, as well as the reduction of accident reduction strategy of Ministry of Road Transport. And thank you very much. I would like to thank my guide Dr. Jitin sir, as well as the collaborative professors from the UCI Ireland, as well as the University of Budapest to get the collaborative research. Thank you.
Thank you, Priya. Actually, we must have interacted with senior scientists of Center for Research Institute, worked on a lot of work on currently on AI ML based submitting approach for the civic analysis, especially Dr. Velumurkar, Dr. Abhishankar, and Dr. Maji. We discuss that more during the interaction. Now, the last presentation of this session is advancement in sustainable
other parameters. And then we have a contour plots. Over this, we can say that the conclusion about this, we found that the stress distribution depend upon the first thing is the type of the vehicle, which is like two-wheeler, three-wheeler or a heavy load, and also the relative placement between the edge of the pavement as well as over the other parts of the pavement. So now coming to the next topic is this mechanistic analysis of rigid pavement using this damage mechanics. So basically in this we are countering of the crack induced in the pavement. Basically it is the objective behind this study is to model a crack propagation in a rigid pavement. So how do we obtain this? So basically the factors upon this affecting the crack are this modulus of elasticity, subgrade, thickness of pavements and the temperature. So we need to have a serviceability on the road so that the user will have a proper smoothness while driving. So utilizing this damage mechanics, making it a platform and optimizing it with the model, we'll get to know that we'll have a strategies to mitigate this crack and enhancing the pavement for the long-term performance. Coming to the last topic of this session, like we have a roadside micro climate considering gray, green, blue and infrastructures. In this, basically we have this UHI, which stands for Urban Island. As we all know, like this urbanization is growing day by day. So there has been a development of this water bodies and the energy consumption, which is characterized like affecting this urbanization, this public health, climate, air and water, energy consumption, flora and fauna. So in this study, they are basically following the methodology of select of locations with the methodological data, create a CFD model using this Navier-Stokes equation and calibrating with the models and showing up how these green values are green climate exchanges. So now at the end, I would like to conclude that in our IIT Gandhinagar, we are currently focus involves development of the highly detailed model to conduct an in-depth analysis of study, payment, and these models are not only the complex, but these are the models that are exceptionally accurate and playing a crucial role in shaping our research methodology, where what we approaches are unique and beyond to this traditional aspect of payment engineering. In addition to that, payment themselves we are dealing with the connection towards the dynamic climate change and the urban microclimatic changes. So, in hence, we are examining the payment from the various perspectives, providing us with the comprehensive understanding of the payment, how they are performing the different environmental conditions. So, this is our research group members built-in environment, where under Professor Sushaman Sen, we are the team of this built environment group. Thank you so much.
Thank you, Angita. Now we have just concluded presentation by 9 scholars, including postdoctoral fellow. Now the house is open for questions and study session. I request each of the interested delegate or expert to introduce themselves and ask the question to the particular presenter and be brief and focus on the questions. Now house is open for discussion. And request the organizer to give microphone to each of the delegates and experts who are interested to discuss on this subject. Please introduce yourself.
Sir, I'm Vikas Thakur from Creative Consultants from Pune. Question to the CGPM author. You talked about full depth penetration. So we anticipate that the CGPM is going to be used as a surface or a wearing course, where the thickness would be between 30 to 40 mm. So what was the thickness of that CGPM in your lab that you have taken for full depth penetration?
We are taking standard thickness, 63.5. Yes.
So I mean, but the
Comparing that with the bituminous mixture.
Yeah.
So I'm going to compare the CGPM performance with the bituminous mixture. So standard size.
So you may just look at, because the code specifies 30 to 40 mm for the CGPM, and you talked about modifying the properties of the grout to actually achieve the penetration,
Yes.
which actually may not be required. So you may just look at that aspect.
Yes, sir. So interconnected voids are more basically because of the addition of wrap. modify the ground to achieve the full depth penetration. I'll look into it.
Sir, I am Dhanesh Kumar from Indian Oil Corporation R&D Center, Faridabad. My question to first presenter, that industry with lignin, that number one, has any cost calculation conducted that how much cost can be saved by using or replacing bitumen? Number two, any test on solubility and PAV test, and after PAV test, BBR and this G star into sine delta test. As these test carried out?
Yes, sir. Actually, I have understood your question. We have not started any economic analysis as of now. And as you asked, like we have not carried out any lot of range performance tests on PAV samples. So we have limited ourselves to big testing. So once we come up with the performance results of mixtures, then we are thinking of carrying on with carrying out the economic analysis for the big materials. So regarding solubility, what is your exact question, sir? No, sir. Actually, in that case, no, lignin is not soluble in trichloroethylene. No, it won't satisfy that things because lignin is not soluble in TC. Yes, but that particular aspect won't be satisfied.
So good morning to you. Yes. So I am Colonel Ravi from the Indian Army retired. I am presently working with Kalpataru Projects International Limited. I had comment query to two presenters. One was Vamsi Krishna and the other one is the use of RAP. We have a road stretch on National Highway where there is a lot of blood resistance and there is defects in the subways also. So can we use both the methods combined together to physically evaluate the test results on the road sample? If so, we are ready to provide all assistance. One to Vamsi Krishna and one to Vishnu Priya. Dandapani, yeah.
So you're talking about the method, whatever I discussed.
Yeah.
So that is applicable for the whatever the mixes as per mixes, but that may not be directly applicable. We need to see the feasibility. But that may be not be applicable to the CGBMs. We need to try about it. But whatever the other mixes, other than semi.
If you are ready to try, we'll provide you all the help.
Thank you so much. So we'll discuss and we'll.
I'll take your number and I'll contact.
Thank you.
Thank you.
There's a small question for the author of this GSB grading. I mean, as aptly pointed out by the convener, apart from the stability, drainage is utmost important. So the IRC talks about 300 liters, 300 meters per day permeability. So apart from the 6 gradations in the north, there are 3 or 4 more gradations specified in IRC 58, which is the rigid pavement. Have you, and they say that the permeability is more in those gradations, which are internationally used. Have you looked at those gradations and tried to see whether how they compare with reference to the permeability of north gradations and these gradations?
Yes. So yeah, the first question everyone will ask, what is the hydraulic conductivity? But in our study, we are trying to focus on more on the internal hydraulic, internal stability. That is the internal erosion that is causing. So once we solve that problem, then we can talk about the hydraulic conductivity. We looked at those gradations; those are also not found to be suitable. So we are working on, first we need to work on the internal stability. Once that is confirmed, then we can talk about the hydraulic conductivity.
I think while explaining on the hydraulic stability, I also used a coefficient of uniformity in addition to coefficient of permeability. We'll see.
Good morning. This is Dr. Jaya from Rasta Center for Road Technology, Bangalore. My question is for Vamshi Krishna. Regarding Marshall RT, can we know the details of the conditioning of the samples? Because it's a combination of both Marshall and ITS, what you said.
It's the same conditioning as Marshall.
As
Marshall stability.
ITS?
Marshall stability.
What about ITS, moisture sensitivity?
No, we have the setup of Marshall stability and ITS we use for the TSR. We combine this thing, but since rutting is happened at the high temperatures,
Okay.
so we maintain the same conditions as the Marshall stability conditions.
Okay. So there's no conditioning as in what we have before and after TSR?
That is not for that. This is for rutting.
This is only for rutting.
Rutting.
Okay.
Yeah,
Only the frame is the similar as in ITS.
Yeah.
Okay.
Frame is combination of ITS and Marshall stability.
And how about the results? Would you consider the volumetrics even in this case?
Yes, in this case also we consider, because this is the plant producing mixes we collected from the field.
Okay.
And then all are satisfied the Marshall mixes method. Then only they started producing, and then we collected that mixes and then we evaluated on the same.
So any changes in the VMA and VV characteristics that you're going to get from this Marshall RT?
We are not talking about any volumetrics from these tests. We are only outcome is the rutting resistance of them.
Okay.
We are evaluating the rutting resistance of it, not any volumetrics also.
Okay. I would want to go through the paper in detail.
Yeah.
If you can share it with me.
Yeah, please.
Thank you so much.
Thanks so much.
Hi, my question is for Vamshi. The experiment what you are doing is a deformation rate control experiment.
Yes, yes.
And you're correlating it to a flow number
Hamburg.
and wheel tracking, which all involves respiretes. Right? Which all involves respirate.
Which all involves the?
Respirate. You're doing a flow number experiment,
Yes, yes.
which involves respirate.
Yes, yes.
So how do you correlate these two? One is a deformation rate control experiment, and the other one is loading followed by a respirate.
Yes.
So when you encounter polymer modified mixes, you may not get a good correlation.
So this is whatever the mixes we involved, which have the polymer modified mixes also. But that question we need to see maybe the polymer highly modified asphalt binder. Maybe we may need to explore more, because this whatever the mixes includes the polymer modified and crumb rubber modified, unmodified, and different type of nominal aggregates is whatever the collected mixes actually.
Okay. Thank you.
Hello, I am from Indian Oil Corporation. This question is for the polymer emulsion person who spoke about polymer emulsion. Is there any Indian specification for polymer modified bitumen emulsions? And have you done it with VG30 also?
Currently, we don't have any specifications for polymer modified bitumen emulsions. In terms of VG30, it can be done, but we should make sure that the emulsion exit temperature should be below 95 degrees.
Okay.
Like the VG30, the temperature at which we add is significantly higher than what we added for VG10 because of equiviscous temperature. So when you add bitumen and soap solution together, the resultant exit temperature should not cross 95. So if we can ensure that, even VG30 can be used.
Okay. So you have restricted to VG10?
Like we had done with VG10.
Okay. Thank you.
Yeah.
Hi, my question, I am Sachin from CRRI. My question is for Shubham, Dr. Shubham. Actually, you have mentioned that grade 5 and grade 6 have internal stability, so you are proposing those two grade to use as a GSB layer. Means, is this internal stability is assessed based on only the CU value or how?
No, there are multiple factors, even the type of loading. Like we evaluated based on experimental, doing some experiments on seepage testing. So there are multiple factors, but just to simplify the understanding of internal stability, we are proposing simple method only CU and CC. So this would be the preliminary method to assess.
Okay. If I want to assess the internal stability in the laboratory, means I have to perform only CU value.
No, if you are going for laboratory testing, there's a lot of testing is involved in that. In order to assess based on preliminary purpose to understand whether a given gradation is stable or unstable, one can use CU and CC value.
Okay, based on CU and CC, you are proposing that G1 to G4 are means not internal stable.
Like we did a lot of testing also on that gradations.
Okay, like permeability test or apart from?
Internal stability test will be doing seepage analysis.
Okay, internal stability assessment using seepage analysis.
Yeah, yes.
Okay, thank you. And one more question for Vamshi. What is the sample size that you have used? Means for those?
Sample size?
Yeah.
So you mean
for analysis? Means how many samples that you have collected from the field? Means plan to develop a model?
We have collected 9 mixes, 9 asphalt mixes, 9 different asphalt mixes.
Okay.
And then for each mix we compacted 4 samples for the test.
Okay.
4 samples.
So 9 into 4.
Yeah.
Okay. Thank you.
My name is Yatin Chaudhary and I am from CRI. I have a question for Ankita madam. Like, what was the inputs that you took for your analysis to develop that model? Like, did you take any crack characteristics, crack inputs for that model?
Hello? Can you please repeat? Pardon?
I'm asking, like, what were the inputs that you took for your to develop the models? Like, did you take any crack?
Like, okay, the traffic data and the thickness of the pavement basically, and the temperature that we are considering for the IRCs.
Okay, and what about crack characteristics? Did you take, like, what is the depth and thickness maybe?
Which?
For cracks.
For cracks, this is this project is just started for now. So this is basic learning, and this is a project like we are going to do in that. So basically in that we are progressing to have a damage mechanics and to build the model so that we can generate the propagation of the crack in that slab. So following the plate theory into that and incorporating these mechanics theories so that we can able to evolve or to model and analyze these things so that we can mitigate this type of crack that's distresses is happening in these slabs.
Okay, so still right now
This
you have
is-
not taken that crack.
No. This is beginnings process is
Okay,
this only.
thank you.
As we are running out of time, we can allow 2 more questions.
Hello, this is Dr. Shashi from ZX Industries. My question is to Dr. Arun, drainage layer design. Okay. So, how you consider this drainage design for the construction of road like IRC 37? Have you considered any factors, reliability factor we will use? Have you tried thing or just only laboratory scale you have done?
Yeah, because drainage we do laboratory only. Field validation is very difficult. Like you need to wait for multiple rainfall seasons in order to access. So that's like a long-term project. We can call it like 10 years kind of thing.
Okay,
But
means you are not considered for the pavement analysis, right?
pavement analysis is secondary. Like primary, we design it for drainage. We get the minimum thicknesses, and then this thicknesses we can incorporate into structure design and then build on that thing.
Okay, thank you.
I think you can discuss more with Professor B. Raghavan, who has done a lot of field assessment with the drainage output, demonstrating how much water can actually come out through the drainage layer.
Hello. This question is for the lignin. Have you used the raw 2G residue, or you have processed the raw 2G residue into lignin and used that processed lignin in your vitamin?
Sir, actually, in that case, in that case, we have used both of the materials to compare the performance. It's okay, keep it. So, in our case, we have directly taken the residue acetus and it has propagated, and that also we have evaluated how it is going to perform. At the same time, we have evaluated the lignin and we performed both. But in our case, like what we observed, like for PG 40 partial replacement, we can go for up to 10% in both the cases. But when it comes to higher dosages, FRO material resulted in like more separation because of its higher density and because of the contaminants present. So we have limited to only 10% and we proceeded further with higher materials.
No.
Is it pure lignin or residue?
Is it 2G residue, raw 2G residue that comes from ethanol plant, or
Sir,
you have
both. We have used both actually, fermentation residue lignin and isolated lignin for our study.
Okay. And you said it's insoluble. You are putting 10%. All the 10% is insoluble, or it's partially soluble?
Actually, we didn't carry out any test on.
Okay.
No, actually the material, whatever we are using, that lignin itself is like insoluble in TC. Even we have carried out some analysis. For example, we wanted to do some Sarah analysis and all. We had to do the solubility test. But those materials are not soluble in TCE. Obviously, those materials will get precipitated when we do the analysis.
Okay, thank you.
Thank you. With this, I will request my co-chair, Dr. Swami, to give his remark and sum up the presentation.
Yeah, thank you, sir. We had a really nice set of presentations, like starting with the fundamental material until the system level, and again within which, like, say, starting from the bottommost soil layer to topmost bearing cores. The first one was on the bioethanol, where, say, which can be a potential alternative, where, like, the renewable sources of the material can be used. Of course, like, the major advantage would be with respect to rutting and potential questions rising because of the fatigue issues. The second one was on the surface modified aggregate, where, say, we have a lot more locations across the country where the good quality aggregate is just not available. When, like, we have this marginal aggregate available, can we go for some of these alterations and then subsequently take it for its payment usage, right? Like, that was the case, like, with the second presentation. The third one was on the CGM mixture, where, say, the challenges associated with the grouting of this material was discussed. One of the advantage which was given was low temperature susceptibility, and potentially this can be advantageous when, like, we have certain locations across the country where significant temperature variation is seen in a given year. Fourth one was on this retaining soil walls, where we often ignore the serviceability issues which needs to be considered, and potential applications over there, and which were shown through numerical simulation. The next one was on GSB material in the pavement usage, where again the ignore component is drainage issues. As long as, like, we satisfy the gradation requirement, we are happy with IRC guidelines or MRT's guidelines. So the other issue, like the hydraulic stability issues from the fundamental material perspective, which was shown through experimental mechanics over here. The next presentation was on use of Marshall RT test, which can be a very simple test which can be used to potentially evaluate the rating issues, which was validated through field mixtures, which is a innovative test setup as such, like, which we have come across. The seventh one was on the polymer modification of this emulsion, which where, say, the SBR latex was used to improve the performance of this material, where the sequence of addition of this material, which is going to play a role, like that was highlighted in this particular presentation. Next one was on decision making process for road safety issues, where innovative analytical hierarchical process was used. Major advantage over here is, like, with limited data, still we can come up with better ranking. Final presentation was on the smart pavements, where the temperature differential within the pavement, that's the rigid pavement with Indian context, was discussed. Again, these numbers which you have in the IRC guidelines, it's pretty old. We require these revised numbers, so that's why, like, we can have this potential application. And of course, the same presentation highlighted on the vehicle type and then the position, which is going to significantly affect the payment response and subsequent damage mechanics involved. With that, like, we have discussed all the presentations. I'm handing over back to Dr. Paul.
Thank you, Professor Swami, for nicely summing up. As a duty, I have to close this session with my closing remark. We had actually 10 presentations scheduled in this session, except SPA Delhi. Rest of the presentation was made starting from IIT Kharagpur, IIT Gandhinagar, IIT Jammu, IIT Hyderabad, most of the IIT and IIC Bangalore. And the presentation we started with partial substitution of bitumen by industry ethanol-based lignine, and we concluded with Gandhinagar presentation on smart sustainable pavement. And where she has possibly has started the research recently, not more progress that I could see in the presentation. But some of the presentations are likely they have done excellent work, which you can see, and the current demand of the society. And the work on drainage, the work on serviceability limit analysis by Dr. Kohli sitting right of me, particularly with the limit state concept, doing a lot of validation, both field and APM simulations was also very interesting presentation, though there was no questions in the sessions. And the drainage related thing has stimulated most of the audience to discuss. And when we talk about modified bitumen, partial substitute of bitumen, bituminous mixes, cement grouted mixes with asphalt reclaimed materials. They actually stimulate a lot of discussion among the audience and the researchers because they are the current topic of demand. Once we are saying sustainable material, and we have to also see what are the alternate material, alternate technology, where the parent material can be substituted by some percentage, and how to use reclaimed material, again with modified technology. And again with, I think one question I should ask that you had taken the cement grouted mix with various type of super plasticizer admixture. What we have seen in cement grouted mix with variation of different manufacturing plasticizer, results are actually different. You might have taken only one or two typical plasticizer in your analysis or the experimentation. In the market, you have varieties brand of this plasticizer. If you take those brands, you will see your results will drastically differ unless you do a proper chemical composition analysis of this plasticizer before concluding. With this, I think we have a very stimulating discussion. I wish all the researchers who are doing their research to conclude their doctoral work, get good publications nationally and internationally. Wish best for their future academy. And those who have already concluded, like Dr. Kohli, who is on the postdoc, we wish that they will do good work in the postdoc related area. And really, I been from the state government of PWD as an applicant and a user, as a client, though I have academic appetite to learn things. My request to all the researchers that focus on the topic which will be really used in the actual design, elaboration, construction. Numbers increase and getting a degree or getting a job. That is only my request to all the researchers who are doing research in this domain of payment. And I am unfortunate, and I just said already in the initial session to Dr. Swami, we did not have a presentation on bridges or bridge-related research article in this technical session. It mostly convert on payment-related thing. So this, I thank the organizer and IRC for giving opportunity to me and Dr. Swami to chair the technical session 1 of the researchers. And I wish all the researchers, scholars, best wishes. Thanks all the audience for their patient hearing and for nice interactive question answer discussion. I request all the delegates who are interested to more interact with the scholars, they can interact during the lunch break and other time. Thank you all.
Now, I request to Dr. I.K. Pateria, Sir, Director Technical, NRIDA, to please come on stage, present a memento to Dr. N.C. Patel, N.C. Pal, Chairman of Session. I also request to Dr. I.K. Pateria, Sir, to present memento to Co-Chairman of Session, Dr. A.K. Swami, Sir. Thank you, sir. Now I request to Co-Chairman of the Dr. A.K. Swami, Sir, to present a memento and certificate of participation to presenters. Presenters name are Thagwani Aditya Sri Vekandas Achilles Dhanam, Sri Surya Narayan S Research, and Bhavanu Priya Dhananapati. Sri Surya Narayan S. Miss Bhuvana Priya. Dr. Kohli Mohan Krishna. Thank you, sir. Now I request to co-chairman Dr. A.K. Swami. Thank you, sir. Now I request to chairman of session Dr. N.C. Pal sir to present memento and certificate of participation to presenters. Dr. Kalero Subham Arun. And Sri G. Vasmi Krishna, research scholar. Sri Arjun PV and Sri Rahul Reddy B. Sri Priyank Trivedi. Miss Ankita Singh. Thank you, sir.
एक बाकी है यार. One more. Please announce. इसके अंदर क्या नाम लिखे है?
Sri G. Vami Krishna.
Just wait. He has not received. ठीक है आ गया. इसको एक बार ले लो. पटेल से बारे में चेक कर लेना आपका. बिना पटेल. बिना सरदार नहीं. Thank you. Now can join in the group. Please come. Please come.